These are notes from section 7.4, properties of logarithms. There are 3 properties of logarithms that we're going to take a look at. The first says log base b of x times y. So if I have a product, if I'm multiplying inside a logarithm, it does not matter what the base is. It could be log base 2, log base 5, log base 10, whatever. We can split that up into 2 separate logarithms and say that's the same as log base b of x plus log base b of y. So notice if I have log 2 plus log 3, that would be the same thing as log 2 times 3, which is 6. Notice I can show that those are the same thing with the calculator. Log 2 plus log 3. Whoops, I typed in log 6 like a dummy. Log 2 plus log 3 is 0.778. Log 6 is the same thing, 0.778. So when I am adding 2 logarithms, I multiply their arguments. I do 2 times 3 to get 6. Or if you have the product of 2 things, you could split it up into 2 separate logarithms if you needed to. So that is our first property. The second one is similar. It says log base b of x divided by y. So if you are multiplying inside the logarithm, you can split it up by adding. If you are dividing inside the logarithm, you can split that into 2 separate logarithms with a subtraction sign in between. Log base b of x minus log base b of y. And the third property, it's really an extension of the first one. Let's suppose I have log a time or plus log a plus log a. Using that first property, I could do a times a times a. So that's the same thing as log a to the third. Well, this is also 3 log a's. So notice what I can do is I can take this exponent. If you have an exponent, again, within the logarithm, you can take that exponent, you can move it out front. So this is our third property. It says log base b, doesn't matter what the base is, of x to the n. We can take that n, move it out front, and say that's the same thing as n times log base b of x. Two main types of problems that we're going to do. The first is we might have multiple logarithms, and we are asked to rewrite that as a single logarithm. So we are trying to rewrite as a single logarithm. So we have log base 3 of 4 minus log base 3 of 2 plus 3 log base 3 of 2. The first thing I'm going to do is use our third property and take any coefficients that we have out front. We can bring those up and make it an exponent. So this is the same thing as log base 3 of 4 minus log base 3 of 2 plus log base 3 of 2 to the third. And then log base 3 of 2 to the third, 2 to the third is 8. And now we're going to add and subtract from left to right. We're going to combine these two first. Log base 3 of 4 minus log base 3 of 2. When we subtract logarithms, we divide their arguments. That's the second property here. If I'm subtracting 2 logarithms, I'm going to divide the argument of the logarithm, what we're taking the logarithm of. So we're going to do 4 divided by 2 which I think we can all agree is 2 plus log base 3 of 8. And then the first property says when I add two logarithms, I can multiply their arguments. 2 times 8 gives me 16. Log base 3 of 16 is correct. Example 2, same type of problem, but instead of numbers, we have variables in there, but we are going to do it the same way. Start with any coefficients we have out front, in this case the 2 and the 3, and we're going to move them up and make them exponents. So log base 5 of a to the second. I think it's easiest if we leave this as minus log base 5 of b to the positive third. Technically, you could put plus and move the negative with the 3, but I'm going to leave the minus out front. Plus log base 5 of c. When we subtract, we want to divide the arguments of the logarithms. So I have a squared over b cubed. And then when we add two logarithms with the same base, we multiply their arguments. So we have log base 5 of a squared divided by b cubed times c. Times c over 1. That's just going to put the c in the numerator here. So log base 5 of a squared c over b cubed. So that is the first type of problem, taking multiple logarithms and rewriting it so we just have one logarithm. The other thing we need to do is take one logarithm and expand it so we have multiple logarithms. In example 3, we are asked to expand into multiple logarithms. Log base 4 of x squared over z to the 5th times the square root of y. So we're kind of doing the same thing we did on the previous two problems, but we're really going backwards. We're starting with one logarithm. Now we want to completely expand it into multiple logarithms. So I've got log base 4 of x squared. I am dividing by z to the 5th. So when I divide within the logarithm, we can split it up with a minus sign. So that's going to say minus log base 4 of z to the 5th. A lot of times I'll see a plus right here because it looks like we're multiplying these two things, and we are multiplying these two things, and when we multiply, usually we put a plus. And technically, you can put a plus as long as you recognize I need to do this first. I am multiplying those first and then dividing the whole thing by that. So you would have to put parentheses around this, which is fine. I think it's easier to say, okay, I'm taking x squared, I'm dividing by z to the 5th because I'm dividing, that's a minus sign, and I'm also dividing that x squared by root y. And because I'm dividing, this one should also be a minus. Notice if you put the parentheses around there with the plus and then you distributed your minus sign, you get here. The other thing we need to do is take any exponents and move them out front. So in this case, I can move the 2 out front, 5 out front, and square root is the same thing as the 1/2 power, so I can take the 1/2 and move that out front. And we have completely expanded into multiple logarithms. Question often comes up, why in the world would we ever want to split it? We had one logarithm, now we have 3. Why would that be better than having the 1? The reason for that is there are some things, especially when you get to calculus, that would be very difficult to do with this function. But if we split it into 3 separate ones where each individual one is more simple than this guy here, so log base 4 of x, that's easier to work with than log base 4 of x squared over z to the 5th root y. Log base 4 of z, again, not too bad to work with, and so on. Example 4 asks us, again, to expand into multiple logarithms and then simplify. So we have the logarithm of 100 r to the 4th. Remember, logarithm with no base written there, it's understood to be base 10. It's called the common logarithm. First thing we should recognize, that 4, the 2 to the 4th is only for the r. The 100 is not being raised to the 4th. I've got 100 times r to the 4th. So we're going to write this as log 100 plus log r to the 4th. And if you want to do it in one step, then we can take the 4 and move it out front. Log 100 can be simplified. Simplify log 100. We should be thinking the base, which is 10, to what power gives me 100. 10 to the second is 100. So log of 100 is 2. 2 plus 4 log r. Those are not like terms. I can't combine the 2 and 4 and make that 6. Just 2 plus 4 log r. We mentioned last class that on the left side we have a logarithm button. That logarithm button right there is base 10. That is the common logarithm. Notice log 100 is indeed 2. Your calculator does have the capability of putting a base other than 10 on there. To do that, you go to Alpha Window, and number 5, notice says log base with parentheses. Again, that's Alpha Window will pull up this screen. Going to number 5 will give you a logarithm where you can enter the base. If pushing Alpha Window does not pull up this screen, let me know. Your calculator just needs to be updated. I can update that for you. So Alpha Window pulls up this screen. Go to number 5, log base, and notice it allows you to type in a base there. Log base 2 of 32 is 5 because 2 to the 5th equals 32.